So today we will discuss three important diagrams, which is called state diagram of the convolutional code. You have already studied it. I have given a lecture on this state diagram in the previous video. So I will just repeat it again today. This is state diagram. This is code tree diagram. The new topic is basically the code tree diagram and code trellis diagram. Okay. So this is state diagram, this is code tree diagram, and this is called code trellis diagram of the convolutional code. And for each diagram, I'm taking example like cconv equals to 212, cconv as 212, and cconv 212. For each diagram, I'm considering the same example. Okay. And depending on this definition of convolutional code, that cconv equals to 212, where 2 is the 2-bit representation of output and 1 is the 1-bit representation of input, and 2 is the number of the delays we are using at the encoder. So to represent these three diagrams, state diagram, code tree diagram, and code trellis diagram, we will use this encoder where S1 and S2 two delays are there, MJ and corresponding C1J and C2J are present. Okay, as output. So what to do? First of all, we have to make a table. You have already know how to make this table. This is called the state table. State table. So this is, you know, from your digital electronics class where the counter was there, and counter for the counter you were you have already used this state diagram, right? So for the counter, we have already used this state diagram in the digital electronic class. So this is also same. We have to make the message, present state, next state, and output. Okay. So very carefully follow this, how to make this table. I'm just repeating it. So there is S1 and S2, two delays. So the possible state, the number of the possible state will be 4. That means 2 to the power k. K is the number of the delay. So possible state will be 2 to the power k. So it will be 4. So I've just written this 4 state as A, B, C, D. Okay. And for each state, I'm considering input as 0. So consider the present state as 0, 0. When S1, S2 at 0, 0. This is in the reset mode. I'm considering the message as 0. Okay. So what will be the next step? What will be the next step? When from the previous lecture, you have already know that this 1 is a new bit. When a new bit will come to the message position, the previous bit of the message will be right shifted to S1. Okay. And that will be the next state of the S1, where the present state was 0. Okay. Very carefully listen. When the new bit will come, this is my present state 0, 0. When the new bit will come, then this 0 will be right shifted to S1, and the bit was present at the S1, that will be right shifted to S2. Okay, because as this is a right shift register, so the previous value of the M will be shifted to S1, and the value of the S1 will be right shifted to S2. So for 0, this is the present state 0, 0, and the next state will be 0, 0, because if a new value will come to the message position, so 0 will be S1 and S2 will be this value. So again S1, S2 is the 0, 0. So the next state is 0, 0. What will be the output? So you have to follow the diagram to calculate the output, because C1 is the XOR of message and S2. You can see from the diagram that C1 is the XOR of message and S2. C2 is the XOR of 3 elements like message S1 and S2. So depending upon this arithmetic performation, this calculation, we have to calculate C1 and C2. Okay, so this is the arithmetic operation we are doing is basically the XOR. Okay. So C1, for C1 message and S2, so 0 0 0, and for C2 all three zeros XOR is happening, so the output will be 0. So when a 1 is present at the message and present state is 0 0, so what will be the next step? Again, consider a new value will come to the message position. The previous bit will be right shifted to S1. So this one will be right shifted to S1, and the present value of the S1 that will be right shifted to S2. So the next state will be 1 0, right? And the output C1 and C2 will be calculated from the diagram. As you know that C1 is a XOR of M, the message, and the S2. So message is what now? Message is 0 and S2 is 0. So 0 0 it will be 0, and C2 will be 1 because C2 is the XOR of 3 element. So 0 XOR with 0 is 0 and 0 XOR with 1 is 1. So in this way we have to make this table. Okay, then I'm defining each present state by this denotation, that like A, B, C and D. Okay, so this is a state of S1 S2. This is also a state of S1 S2. So when this present state 0 0 becoming the next state, and this is also same 0 0, that means if I consider present state 0 0 as A, the next state is also A. When the condition is when the message is 0 and the output is 0 0. Okay, very carefully listen that we have to draw the state diagram and all the three diagrams like state diagram, code release diagram, code tree diagram, like this, that when the present state is converted to the next state, always we have to write the condition. What is the condition for this? When A is converted to A, the condition is message will be 0 and output will be 0 0. Okay. So this is the condition when 0 0 is converted to 0 0. That means A, the present state A is converted to next state A. The condition is message is 0 and output is 0 0. In this way, the present state is 0 0. That means A, and it converted to next state, which is B. The condition is message should be 1 and output is 1 1. So likewise, you can say that when C, I'm considering this is C as a present state. So C will be converted to A. C will be converted to A. That means this state, which is 0 0, and C will be converted to B. Okay. Also, D will be converted to C, and D will be converted to D again. So for this, when C will be converted to A, the condition is the message is 0 and output is 1 1. When C will be converted to B, when message is 1 and output is 0 0. Likewise, when D will be converted to C, when the message is 0, this 0 and the output is 1 0. When D will be converted to D again, that means we are using the self loop. When the input is 1 and output is 0.